Alright, so question 9. Which of the following alcohols would dehydrate most rapidly when treated with sulfuric acid? So give us a bunch of them. It's H. It's 1. It's 2. It's 3. 4. And that's 5. So the acid that we're using is H2SO4. So the first thing that's going to happen is going to be protonation, right? This acid is going to protonate. So all these oxygens from all these different alcohols are going to be coming down here, grabbing this hydrogen. They're all going to want it. So that would be the first step, would be protonation. And then step 2 would be elimination. E2 elimination. Okay, so and that will create an alkene. Right? So we're going to look for the most substituted alkene because it is the most stable. Right? Now, out of all of them, so if you look, the difference between all of them, this hydrogen is, this hydroxyl group is connected, there's an H. This hydroxyl is connected, and then there's a methyl connected, and this is a hydroxyl. An H. An H. 2 H's. The only one that's really different than the other is this one that has 2 H's, so that's going to create only, it's going to create a dye substituted. That'll create, I think, a dye substituted. Yes, this would create, or maybe it would create a mono substituted, because the H would have to come from here. It would create 1, 2. That would create a mono substituted. Anyway, the one that's going to create the alkene that's the most substituted is this one. 2 would create most substituted. It would be tri-substituted, right? So here we have our alcohol. Here's our protonated water group. So this A is going to come, this is the acid, this is the conjugate acid of the sulfuric acid. It gives up one of its H's. So now it's, here's the conjugate base. The conjugate base comes, it takes a hydrogen. That hydrogen gives its bond. The water breaks off. You know, and that just becomes water over here. And this becomes, we have the double bond now, and the 1H. It's tri-substituted. So it's the most stable. So that's the one that would most readily undergo dehydration.